In this short video, I just want to show you a couple of things that you can do with the pressure vessel model. First, we can insert a coordinate system. So we can put in the coordinate system and we can choose type. So if I change that to cylindrical, we're going to have, now we need to define an origin. So if I click on here, I just want to pick, it really doesn't matter which one of these. Let me switch and grab a vertex. Okay, so that's the center on the axis. See how it updated. It's showing right now that my X is radial and the Y is the rotation direction. And that's wrong, and the Z direction's in the wrong direction. So I need to reorient that. So we can see our principal x-axis is the x-axis, and that works for us. So principal y, now I want to change this, and I can select a different one. So I can do the z-axis and say I want to line that up with the global y-axis. Okay? So now you can see that we've got radial on the x, particularly if we think out of the cylinder, cylindrical, and the axial. And so that should be, it's green check, it's all created. The other thing I could do is create construction geometry. Now, if you don't have any construction geometry, you won't see this box over here. So I come up here on the model, insert, construction geometry, and we want to do a path. We created one before when we were doing the shear moment diagrams of the beams. And this is very similar. So we can come in here to the path. I can select 2 points. So I could select 1 point and apply. I could select the second point, and apply. Okay, and I've got a point there, and I could rename this cylindrical. And I could just call it cylindrical, but I already have one cylindrical, so I'll make it cylindrical edge. I could also insert a path, and I could, instead of doing 2 points, I could select an edge. So we could click. We select edge types, and so we could plot that. You notice I could do it along a curved. I could do it along a series of edges, whatever I wanted to do. I'm going to select the edge, apply. Now, when I create a stress, I have an equivalent stress. Now I could insert another stress, equivalent von Mises stress. And now when in the scope, I could select it to the path, and then I could say that hemispherical path. And I could create another one, something that's rename that. So we could say end stress, and let's just duplicate that. And we could change the path now to the cylindrical edge. And okay, and then let's just rename that. So we could call that cylinder. And now I can evaluate those. What you see is it shows it in here qualitatively in a color scale, but I can also get this plot, the graph, and I can look at this in tabular data. So I could export this. So if I wanted to make a plot and compare it to the stress I calculated through the thickness, then I could do that. I've got cylinder, and you can see the different values here. This becomes really helpful in understanding the stresses. I've made a couple plots in here. I just want to show you a couple things here. So I have a normal stress plot. So this is x-axis. And notice my coordinate system. Let me rename that. So Csys. Okay. So if we come down here, what you can see is I'm using the cylindrical coordinate system. So my x-axis is going to give me radial stresses, normal stress 2. This is going to give me tangential stress. The normal stress 3 is going to give me the longitudinal stress. Now, that is true. That definition is true in the cylindrical section of the body. When I come up to the hemisphere, those directions change. And so the longitudinal stress definition no longer fits in that region. The tangential stress should still be a tangential stress. The radial stress is also a tangential stress. So in those regions, we get different results. Where it doesn't perfectly line up. So this just works in the cylindrical region. I could also plot my different max principal stresses, and I could put contours on the ends. So my maximum principal stress is middle and minimum should also align with the stress states. So my minimum principal stress is my radial, because that's compressive on the inside, going to 0 on the outside. My middle principal stress is going to be the longitudinal, I believe. Let's see. It's like we've got, and my maximum principal stress would be, I think, should be the tangential stress. And you can see how that, or the hoop stress or tangential stress. You can see how that peaks at the inside and goes out. The middle is uniform in the cylindrical section. It doesn't really have as clear a definition over here. There's some transition regions, which is what makes this vary. So, if I think about the stress components, what I know from my models, then I can learn a lot from the data. So I'm going to give you a version of this that's missing some of these files that you can create and play with to help you understand the different stress components without having to do a lot of work for it.